Hi, everyone. We're back with our YouTube channel, Boiler Built Construction. And today we welcome Dr. Jungsong Zhang from Purdue University. So Dr. Zhang, thank you for coming and talking with us a little bit more about research in construction.
Thank you, Dr. Debs, for inviting me.
You're welcome. Do you want to give a little bit of a background from you before we start the interview?
Sure. Hello, everyone, and it's my great pleasure to talk to Dr. Debs and talk a little more of the research that we're doing here. And my name is Jiansong Zhang. I'm an assistant professor, colleague of Dr. Debs at the School of Construction Management Technology at Purdue University. And my research focus on enhancing the industry with various types of technologies, especially the building information modeling, artificial intelligence, some virtual reality and construction robotics. And some of the main themes we try to focus on include sustainable built environment, construction automation, plus other construction engineering and management tasks. So again, it's my great pleasure talking with Dr. Debs today. Thank you.
Thank you. And I guess we will have some time to also dig deeper into a few of those topics, so stay tuned. So let's start with the questions. First of all, how do you define research in construction?
That is an excellent question. Thank you, Dr. Debs. I feel, nowadays is probably the best time to do construction research because, the data shows that our construction industry has been lagging behind other non-farm industries for decades in terms of the productivity improvement, and significant portion of that was related to the relatively low adoption and the development of advanced technologies in the construction industry. So I would say a lot of my colleagues and friends in the community nowadays, we are focusing on how to actually better develop and integrate various types of computing technologies into the construction industry so that we can help improve its productivity, efficiency and safety and working conditions for the workforce, so on and so forth. So that is just my probably biased view of construction research. Obviously, construction is not a standalone. In other words, it's not isolated from, let's say, architectural and engineering. So typically we say AEC industry, right? Architectural engineering and the construction industry. So, again, a lot of the technologies such as BIM, AI, VR, construction robotics, there are great potentials for integrating them into the AEC industry to help push the industry forward. That's my understanding.
Perfect. So now, building on that, in your opinion, how partnerships between universities and industry can move the construction industry forward?
That's another great question, because the construction research cannot be done without the actual data that come from the construction industry. So it is critical that, we, from the academic side, we would like to partner with industry so that, it can be a very synergistic win-win situation that the industry can provide with some of the pain points they're facing or some of the critical problems they're trying to solve. And at the same time, they can provide the real data, project data. And then from the academic side, we researchers, based on our expertise and experience, we can, delve into specific topics that tie to the problems that industry is trying to solve. And then hopefully we can figure out some potential solutions that might be, helping the industry moving forward. So I think the partnership between universities and the industry is especially important for the construction research. Because we are not just purely theoretical research area, right? So we need to have a very solid foundation in the real world.
Very good. So now delving into like topics, what do you see as hot topics of research that can really improve construction industry as a whole?
Thank you so much, Dr. Taps. This is another excellent question. I'm a huge fan of artificial intelligence, and I basically came to AI book when I was in my sophomore year, and fell in love with AI. So I think one of the hot topic is gonna be AI, and of course, it's a very broad area. It involves natural language processing, computer vision, logic-based reasoning, and various other computing tools and techniques. But I think overall, there are many places that AI can come into play to improve the productivity, health, and safety for the construction industry. But it's not the only hot topic. Obviously, there are many other related, I would say, technological domains. And building information modeling is definitely a very hot topic. Many people are working on BIM-related research and education. And some of the visualization techniques, virtual reality, augmented reality, and construction robotics. These are just few of the many hot topics, I would say, nowadays in the construction research. And as I mentioned earlier, I think this is the best time to perform construction research, just because of the availability of vast number of different technologies and their fast development. Plus, there are problems in the industry that we would like to solve, such as the workforce shortage. Many people are talking about the workforce shortage in the construction industry, and some survey shows 70-80% of the companies are facing problems or difficulty in finding the people to fill in positions in the workforce. So this is one area. For example, automation technologies potentially can help. A lot of times we can see research that are working on, let's say, human-robot collaborations. So under the vision that in the future, the construction job site may integrate a lot of automation and construction robotics technology, so that in order to prepare for such a future construction job site, then we would like to prepare the workforce to get ready for it. Just to name a few.
So I guess if our listeners are students or prospective students, they might see a very different job site reality once they're out in industry. So stay tuned. Now moving on, particularly to residential construction, what advances do you see happening in the field in the next, let's say, 5 to 10 years?
Okay, that's a very interesting question. Residential construction, just in my understanding, I mean, it's a very important, because we all live in some sorts of, apartments, houses, whatever, residential units. But from the business point of view, I mean, correct me if I'm wrong, but my understanding, this sector of the construction industry may not have a very large profit margin. And there are a lot of small business, small contractors playing in this field. So my understanding is that the residential construction has been even sort of lagging behind some of the other types of construction in terms of integrating new and advanced technologies. So in my opinion, as technologies are becoming more powerful and more affordable, I believe in the near future there will be a lot more integration of these various types of technologies into the residential construction domain. For example, back to some of the topics I mentioned earlier, like building information modeling. A lot of companies are using BIM software nowadays for various types of analysis, with it either being architectural design, construction management, structural analysis, energy modeling, simulation, you name it. There are so many types of analysis that can benefit from the use of building information modeling just because of the very rich data and the information that's available in the building information model. And nowadays, if you walk around many different job sites, you can see people pull out the UAVs from their truck and fly it throughout the job site to maybe monitor the progress of the job site, or for safety or other type of security. There are many different types of applications. You may equip the UAV with cameras and a LiDAR, different types of sensors. You can also leverage a certain computing algorithm to help you, let's say, automatically calculate the quantities of the soils that have been excavated, things like that. So I think in a nutshell, in my vision, that in the next 5 to 10 years, we're going to see a lot more of these types of technologies integrated into the residential construction area, just because of the availability and affordability of them.
Very good. So now let's focus a little bit more in your current research. Can you describe in a few words, because I know all researchers like to talk about their research, your line of research, and why did you choose that specific line of research?
That's my favorite question. Thank you, Dr. Debs. So my lab is called Automation and Intelligent Construction Lab, in short, AutoSC Lab, Intelligent Construction. So I truly believe in the power of automation and artificial intelligence, and I believe they can bring, a lot of benefits to the construction industry. So that's why my research, if you look at my publications and research projects, they pretty much focus on how to further develop these different types of technologies and harness the power to help our construction industry, with it either being for construction automation, to help with reducing the pressure on the workforce, or helping alleviate the workforce shortage problem, with it being, for sustainability and resiliency of the built environment, because, nowadays, because of the climate change, there seems to be more and more, different types of extreme weather and even, natural disasters happening. So we want our environment to be more resilient and more sustainable. And all of these technologies I mentioned, various types of modeling and sensing technology can be integrated together to help us better understand what was the plan, and then from the actual execution point of view, also can use these different types of sensors, like cameras, because every job site has a camera, right? So that's the mostly available type of data will be the image data. Other types of sensors like laser scanner and IMUs, all the different types of sensors, we can use them to collect the as-built information, so that this can be compared with the as-design information, so that we have a better idea and understanding of what actually is going on the job site. My research was actually originated from this one main application, which focus on code checking, because when you have a building design, before you break ground to construct that, you want it to be, or it has to be, issued a permit by the authorities having jurisdictions, and in order to get that permit, your design needs to be checked, by comparing to all the related rules and regulations. especially building codes. And for those of you who are familiar with the North American building codes domain in general, we pretty much adopt some version of the ICC code, right? International Code Council. So my PhD dissertation actually has been focusing on how can we improve the the objectivity and the efficiency of the code checking process by leveraging the automation and AI technologies, such as natural language processing, which can be used to automatically interpret the rules and the regulations that come from the building codes, and then put them into a computable format. And for example, we can use logic representations, which later on can be automatically reasoned about using the we call them logic reasoners, so that the information that comes from these regulatory rules and the requirements can be used to automatically check if all the design details are compliant with these rules and requirements. So by and large, the main goal was to automate a lot of the steps in such a compliance checking process, so that we can help improve the efficiency and the objectivity of such checking. And nowadays, just sometimes the authorities having jurisdictions, they may also need such type of technology, because they need to review a lot of designs in a short period of time, and the submitters may not be patient to wait for a very long time to turn around, things like that. So that is one of the main focus of my research, is on automated building code compliance checking. And starting from there, over the years, we gradually extended towards other application areas, such as robotics in construction. So you can see in my background, this is our famous D. Dorsey Mouse construction lab at Purdue University, and it's a fantastic facility where we can test various types of technologies, in terms of how they may be integrated into the construction process. So one of the areas that we have been, scratching the surface, I would say, is how to better integrate the robotics, technologies and equipment into the construction process. And sometimes, if you have, robotics equipment that is too large to be directly tested, or in some cases, this might be equipment that do not exist yet. So we started with simulation, right? With the help of building information modeling, we can create the, the basic environments plus the building elements and in other words, building blocks that can be manipulated by various types of robotics equipment. And this can be done through the help of the logic-based reasoning, which can help us check, okay, can this robot reach that far to grab that beam, with that heavy load, things like that. So this is one area which I think is very promising, because in the future construction job sites, a lot of us envisioned to be a collaborative environment between human workers and robotics equipment. So this is one of the areas that we have been focusing on. Another area that we started, I would say, in the last 2-3 years was how can we leverage these different types of technology, not just for the buildings construction, but also for the the highway transportation projects, or another name is heavy civil projects. And that is because, again, we want our built environment to be more sustainable and resilient, and our environment is changing a lot. So how can we harness the power of the AI technology, the building information modeling, and all of these to help us design and construct a more robust structure that can last longer, withstand more harsh environments. This is something that we have started working on in the last 2-3 years as well. I think I can stop there. Thank you, Dr.
Well,
Bench.
you can stop there, but then I'll also ask you if you can briefly describe a recent research project that you have worked on and talking about motivation behind it, what was the industry involvement, and some results that could be shared with our viewers today.
Sure. So I think the automated building code compliance checking is still my favorite topic, which I have been working on since my PhD journey. That was, like a decade ago. So one of the milestones that we have achieved in the, I would say, last 1 or 2 years, we were able to push the computing algorithms, based on NLP, natural language processing, AI, logic-based reasoning, and building information modeling, etc. We were able to achieve 100% recall in non-compliance detection in our experiment.
Can
that
I
is not
interject
yes.
for a moment? Could you explain to our viewers what recall is? Some of them might not be familiar with the term.
Yeah, very good question. So recall and precision, these are two commonly used quantitative measures to help us gauge the performance of computing algorithms. So precision means, from the code compliance checking point of view, if we are looking at the non-compliance detection, for example, precision will mean, let's say, if you have, or your algorithm has identified 100 non-compliance instances, then out of these 100 instances, how many of them are truly non-compliance cases? So this will be captured using precision. And recall is the other way. Recall means if there are, let's say, 100 non-compliance instances in fact, then how many your algorithm successfully, identified or extracted? So in other words, there is a trade-off or balance between precision and recall, because if you push it to the extreme, let's say, I can just tell my algorithm to treat each and every design detail to be a non-compliance instance, right? So if you push to that extreme, then you are guaranteed to have 100% recall because you treat everybody as non-compliance. But your precision can be low, right? Or the other extreme will be, I only pick 1 or 2 non-compliance cases that, I'm pretty much sure these are real non-compliance cases. But in that case, the recall can be low, right? There might be a lot of non-compliance cases missed. So, to sort of balance these two measures, there is another measure which is called F measure, or a more commonly used version of that is called F1 measure, which will be the harmonic mean of precision and recall. So if you think of P to represent recall and P to represent precision and R to represent recall, then the F1 measure will be 2 multiplies P multiplies R and divided by P plus R. That would be F1 measure to more comprehensively evaluate your algorithm. So again, back to the code compliance checking and non-compliance detection scenario, 100% recall will mean that I'm pretty sure that all potential non-compliance cases have been detected. Although, some of these might be false alarms because the precision is not 100% yet. But, that at least we can provide these non-compliance cases so that, authorities having jurisdictions, it will be much easier for them to go through just this list of potential non-compliance cases instead of, let's say, hundreds or thousands of, other or all the design detail instances.
Okay, very good. And so what was the industry involvement in this project?
That's a great question. So, I felt very lucky when I first started at Purdue, back in 2017, and shortly after, um, some industry reached out to us, such as the Indiana Construction Roundtable, plus other companies, nonprofit organizations, and we were also, through help of Professor Brett Banhart, that we also have very good connections with the Department of Homeland Security Building Commissioner's Office, um, which they all provided very valuable inputs to this research because it's their daily job. If you are familiar with the Building Commissioner's Office, the design checking and permit issuance is one of the main jobs that they need to work on each and every day. So this is a perfect, I would say, opportunity for me to further test and development some of the technology that are already developed since my PhD study. Um, so, this was, I would say, a dream project that we have been working on. And Dr. Debs, you are also involved in this project as co-PI, right? So the industry has been fairly engaging in the project, by providing us with the real data. Again, this can be some example building plans. This can be building information models. This can be other types of data. For example, it might be compliance checking reports generated by existing code review software like Smart Review tool, things like that. And we also have a regular meeting every month. And this is a meeting that the whole research team, including all the PI, co-PI, senior personnel, all the graduate and undergraduate research assistants, we will, sit together a lot of times virtually because, our industry partners are all over the geographical areas. With our industry partners and, government partners, we talk through what has been the progress in the past month and what were some of the challenges we're facing, and everyone can contribute in terms of potential solutions to help pushing this project forward. And of course, we were very fortunate to have the support from the National Science Foundation through the Partnerships for Innovation project, which we were awarded this back in 2018, and it was still under the IIP division in the NSF, which belongs to the Engineering Directorate. But now it has been moved into the new TIP, Technology Innovation and Partnership Directorate. So, in a nutshell, this Partnership for Innovation project, it's, as you can see from its name, it emphasizes partnerships. So there has been very significant involvement from the industry, from the government agencies, and we really appreciate that. This really helps us push the research progress much faster. And otherwise, I could not, I would say, achieve this 100% recall, as fast as what happened.
Perfect. So now, shifting, but not that much, I want to talk a little bit more about undergraduate research. So what do you see as benefits of getting involved in research projects at the undergraduate level, specifically for construction students? And how do you think the skills they learned in the research could translate to even an industry career?
That's a great question, and thank you for mentioning this, Dr. Debs. I think one thing that we are trying to cultivate our students with is the critical thinking capability, and I think any research experience is very helpful in cultivating that. And for myself, my bachelor study was also in construction management. But like I said, when I came across this domain, which is called artificial intelligence, in my sophomore year, it just, it's opened my eyes, and I fell in love with AI, and decided that if there's an opportunity, I would definitely pursue something that will be related to this. So that's what encouraged me to pursue, master's study at Carnegie Mellon University, and later on a PhD study at the University of Illinois, Urbana-Champaign. I think, any research experience, of course, it depends on if the student can accommodate it into his or her busy schedule. If there's any research that you can take, I will encourage you to try to take on that opportunity and challenge, because it will open some doors or windows which, right, which probably is not directly available to you through some of the traditional curriculum, especially for the construction industry, where it's changing so much nowadays. Let's say 10 years ago, if you go to a job site, you probably will not see a UAV, right? But nowadays, it's all over the place. The technology is advancing so fast, and for construction and research community, a lot of us are, focusing on integrating and developing these types of technologies into the industry applications. So I would say, from that point of view, research experience will be very useful, even for, let's say, your actual industry job. Again, I will still use the UAV as a classic example, right? If you already have been exposed to the UAV and the LiDAR data, camera data collection and data analysis, data processing through some research projects with some professors, with some labs, then you will have a much better understanding of these types of technologies, which can help you when you use them in your job site. And again, that's just one example, and the list can go on and on. There are so many tools and techniques, and I would say research projects can be a very good way for you to get exposed to the most cutting edge of these technologies, and how they might be used and leveraged in the job site.
Very good. Thank you. Thank you so much. And just for our listeners, UAV is kind of it's unmanned aerial vehicle. So think drones. I'm not sure if there's a significant difference, but essentially it's those types of it's drones. So thank you very much. And that means, if you're interested, seek out a professor or a topic and just make yourself available. And those are skills that can be used in life. So thank you, Dr. Zhang. Very great introduction, very high tech for our listeners.
Thank you, Dr. Debs.
And we will hope that a lot of the things that you're seeing will be coming in reality. Some of them, as you said, it's already there. So a lot of changes are coming, and our students need to be very much on top of what's going on and what the future takes, what can be coming of the future. So if any viewers have any more questions, could they reach you at your lab? So if you can share with me, I can put your lab website on the video, and then our viewers can get in touch.
Yeah, that would be great. Thank you, Dr. Debs. And my lab is always open to any interested students. And in fact, there have always been at least one or two undergraduates, students involved in my lab at any point in time.
Yeah. So if you're interested, please reach out to Dr. Zhang at Purdue University if you want to know more. And you can also reach his webpage with a lot of his research and just get involved. Thank you so much. Thank our viewers, and have a great day.